Hey,
Hey, happy
Happy
Friday.
Friday.
Currently
Sebastian,
at a
thanks
hotel
for
lobby.
stepping up.
Yeah, no, happy. Always happy to present.
It's awesome.
Does
You said hotel lobby. Where are you traveling?
We're doing an offsite in Cancun.
Oh, I'm jealous. Is it warm?
Yeah. Oh, dude, it's so good. Yeah, it's so warm.
I'm so
I got burnt
jealous.
today. Look at this. This is like actually a mark of pride. I don't know if you see the burn.
Yeah. Well, and here I was hearing from my some of my coworkers in the Northeast. They're like, it's -8 today. And I'm like, Jesus.
Yeah, no, I'm not looking forward to getting back.
Scott, you're in New York, right? What's it like where you're at right now?
ice cold. And we still have like 6 inches of snow on the ground from last week's snow.
Oh, wow, from the storm.
Yeah.
That stuff. Wow. Okay. If we're ready, I go ahead and kick it off. I
Yeah, I'm gonna
Yeah.
ping the channel, but you can go ahead. Don't wait up.
Yeah, go for it.
Okay, give me 1 second. Okay, so I do need to make a disclaimer that I did not have too much time to like work on the actual recursive language model implementation, um but I did like work on an alternative. I Okay, tell me if this is like tell me if I'm ever incoherent. I'm at the lobby, so if it's loud, just like tell me to repeat. Um, okay, so there's like two things that I did. One was my interpretation of what a recursive language model was before I actually knew what it was, based on like very little data. That this was before the MIT paper that like kind of coined the term, I guess. Um, and this was from Poetic, and I'll post this. I guess I'll start sharing my screen. Let me verify. I'm not showing more than I should. Okay. All right. Um, okay. So poetic. So this was the first thing that like got me interested in like recursive language models. That they were doing an interview, um, and in the interview, it was really hard to like grasp it as to what like they were actually building. Um, but there was like one thing that did stick with me, which is the idea of like um, creating this thinking system, like basically this new form of thinking that uses some kind of like algorithm to compress information or allow it to like do some kind of like more complicated thinking as opposed to the linear thinking, which is just basically token after token after token linear sequence. And so what they basically mentioned that kind of like spurred me to like try building what I thought was a recursive language model was they mentioned um they mentioned backtracking. And when I saw backtracking, I was what how I interpreted that was basically as a tree of thoughts. And so the original premise of that was what I'll show you here. Um, so let me see if I can find a good snapshot. I'll get into the code later, but I want to start off with visualizations. So let's do that. CD zero first CD trees, tree search thinking, CD UI, npm run that. Okay, so I'm gonna get that, and then I'm gonna get a snapshot that has a bunch of actions. Okay, action log. I'm gonna get this snapshot here. I'll go over to this, um, and then throw that in here. Okay, so this is basically what I was hoping the model would do. And this is not a very genuine example of what the agent does effectively, but it kind of communicates the idea. Like the agent actually did generate this, but I had to do a tremendous amount of hacks. Like if you look at the GitHub repository, it is a disgusting mess of just hacks all over the place, and I'll get into why that is. But just to like motivate the problem. So let's say you have a very complicated question that needs answering, and you need to like just like a math problem. You're gonna go step by step, And then eventually, like down the line, you're going to realize, oh, you made a mistake, and then you need to backtrack to a certain point and start from there. Um, and the hypothesis is that if a model just gets like stuck in a certain path and might not be able to effectively backtrack. And if it does try to backtrack, the context keeps on growing like linearly. So the idea here is to prevent that like linear context growth by basically providing it this function to be able to go back to any node and then go through a different branch and only expand the nodes that are relevant at that point. Like for instance, here I don't remember what the question was. I guess some technical question about databases. And so it basically went through like it went through a thought here, and I cannot really expand this. I don't have that. I don't have that enabled in the UI, but so this is this initial thought, and note that these thoughts are not at a very low level. These are I built an agentic system to represent thinking, and how I did this is I basically have a GPT-4 model with thinking disabled, and I tell it to just like have like very short, or actually, um, I tell it to one make a brief as it's basically thinking through things. It makes a brief and reasoning, and the reasoning is well, actually it's first the reasoning and then the brief. So the reasoning is basically the lengthy thought process of uh, basically a complete thought, and then the brief is just like a snippet of that thought. Um, well, not a snippet; it's just a summary of the thought. Well, what the objective here is that brief is smaller than reasoning, but it still conveys like the general idea. And so as you step through this, like you're gonna see that it's like building on top of it's building on top of the reasoning. Um, it's creating like as it's thinking through, it's basically creating like a linear chain of thoughts. But if at any point it feels like it gets stuck, as it basically did for all these other instances, it'll just backtrack back to whatever relevant node. And in this case, this actually shows like one of the limitations. It's every single time, it's never actually branching off of it's never branching off of like a previous thought. It's branching off of the root. So it's just like completely starting from scratch, which I don't think is very useful. Um,
Question. So when you say that it's doing that, is that resetting your context window so those nodes are not in there
yeah,
at all?
no, no. It still has context of the briefs, but it doesn't have the reasoning.
Got it. So it goes down that, but then it resets and it's like, oh, both I have those briefs, I went down those, and that was a dead
Yep,
end. So it has
yep,
that information. Okay, interesting.
yep. And there's a big caveat to this. So one of the interesting things is that like as I just mentioned, it is always going back to root node. Um, and if I had spent more time like trying to figure this out and trying to like hack through like my intended like workflow or like the intended thought flow, I would have liked it to be more dynamic. I would have want branches to like go back to like halfway through its thought process and be able to identify, oh, this is where I went wrong, and then I don't know, something more reasonable than just like starting from scratch every time. Um, but this is like entirely up to the language model where it decides to like start again, and it's deciding every single time to start from root. So that's like one of the issues. The other issue is that this is actually not representative of what the model normally does. This is a constraint that I gave it. Like after a certain amount of stuff, like hard constraints, it's basically logic. If at any point it like exceeds a certain number of linear thinking steps, it has to backtrack because there was nothing. I couldn't do anything to get it to like backtrack ever. It is entirely possible that there might be like a bug in my code, but I tried. I tried really hard, and I didn't find anything. It's just I could not get the model to like snap out of like this linear thought process and just like um backtrack back to a certain point in its thinking process.
Did you
Um
try
yeah.
inserting yikes yelling, but actually, or on the other hand, because
What is it?
I think we had a
Extremely
discussion about
effective tactic. I highly recommend it.
we had this discussion at some point about how like when you see like particularly like coding model or coding harnesses and you watch their thought traces, they'll do things where they go back and like one of the tactics that's used is the harness will literally inject the prompt. But on the other hand, or looking at this another way, and that like
Oh, that's
pushes it
funny.
off in another direction. And so then we had this whole joke about Yikes going around parties doing that. And he's just like, on the other hand, and then walking along.
Okay, that's funny. Um,
Be a good hackathon
how would you
after
even?
falls, Make sure everybody's on whisper flow and just like walk around and yap it.
So yeah, that's actually like a pretty relevant idea. And it's kind of a joke, but it is actually relevant. Like,
Well,
how would
yeah,
you actually?
No, I do think it is relevant, right?
harnesses
Like
use it. Yeah, they unironically do, or
this
that
is a
was one of the
tactic.
tricks. Yeah.
Yeah. So how would you go about doing that? Because the but actually would need to happen spontaneously. Like, but
So
actually, let's
so
go back to node X.
so most APIs allow you to actually insert content. One way you could do this, right? If you're using, like, for example, the chat completions API or something like that,
Yeah,
um,
this what this is using.
insert a message as the assistant, even though that you didn't get it back from the generator. There's actually, let me think about that again. End message, and then see what it generates, right? Or
Like as
like,
part of the stream,
yeah,
like in
at
between the stream
no,
process.
at as your most like you're going through. I'm using the chat completions API because it's in some ways the simplest. That you could do
Hmm.
this in others, but like you're literally handing it a list of chat messages that have happened, right? And right now
Hmm.
you populate it based on it sent me a thing, so I label that as assistant. Then I gave it a prompt, I label that as user, and then it sent me a thing, and it sent me a thing, like all of those different things, right? But
Okay.
you can inject content in there, label it as if it sent it,
Oh yeah,
that
the
it never
assistant.
said, right? You can rewrite its
Uh,
history, or one
yeah,
way you could do that is rewrite and say, "Oh, actually, I need to think about that again." Just like throw that in and see what happens.
yeah. So
Um,
basically, as opposed to just like appending the default assistant message, you would just do default assistant message plus what actually.
yeah, you could do that. You could
Okay.
do. There's a few different things. Now, another thing on this is most of the APIs do expose a way for you to pre-fill the first part of the response that you're asking it to generate. So instead of
Oh,
just
cool.
here's all the completed ones, you say here's all the completed ones, generate a response starting with these tokens. And so that is also a way that you can do this. There was a really interesting side note of like how Manus would use this to prefix filter the set of function calls that were available because they had their outer agent loop structured as it was only calling functions, and then they
Hmm.
would say, right now, I only want to expose a certain set of functions, but I don't want to keep changing my context window to only expose those functions. So what I'll do is I'll just have my entire function list, but I'll ask for a generation where I pre-fill enough of a prefix that it filters down to the set of functions that I want it to be there. Um,
But why not just filter the functions?
because in their case, my understanding is that because every time you change which functions are available, you kill your cache,
Mm. Yeah,
right?
exactly. Yes.
Yeah.
Yeah.
Because you're changing it. They wanted to have that all in there once. It's all in the cache, but still at different times filter to different sets of valuable ones. And the
Hmm.
hack they did to do that is they started the response so it could only do functions starting with F or whatever it is, and then they had all their functions like carefully prefixed to be able to do that
Wow.
in a smart way.
Wow. So that's like basically constraint generation, or like they started the constraint generation response.
Yeah, exactly. They're constraining the response by
Wow.
just filling in the prefix of what it can come out, so it can only generate
Mm.
further pieces of that.
Yeah, you could
Yeah.
Yeah.
also you could also take the approach of like a structured output if you're doing it in kind of a graph format like you're doing here. You could just have a but wait node, and then you could occasionally inject that just like at a semi-random interval, just to see if you can get a few more nodes on the tree, something like that.
Yeah. I want to show you what the actual tool call is. Let's see if I tool or function. Oh, okay. Where is the actual tools? First thinking evaluator prompt. Oh, yeah. Okay. So one thing I had to do was like I had to separate between the thinker and the evaluator, and I think the reasoning for this was again frustration that I just would never backtrack, just to be able to like have independence of the responsibilities. I thought this might have been the problem, that it was just like too loaded of a responsibility to both think and backtrack. And also like I kind of wanted I think it makes sense. I think it's very reasonable to like have just an agent that's intended to think, and then an agent that's kind of like an adversarial agent saying like, "Oh, you've thought wrong. Go back." So, and this one tells you like how back you're supposed to go. Um, so oh, and I also like hard coded this thing. Um, so it's basically thought. There's a thought followed by an evaluation. It's basically a loop that is a thought followed by an evaluation. That's what happens. And then if evaluation is null, I think you'll see it here. Continue reasoning, move to node and finish. These are the three conditions. So if it's continue reasoning, then it'll just do nothing. If it is finish, then it'll conclude the loop. It'll exit the loop, and then move to node is when it actually I think it tells it says specifically target node ID. Okay, yeah. So it basically fills it gives the target node ID to what node to move to, and for whatever reason, it always asks for returning back to root node. Yeah, so that's basically how the evaluation is being handled. What you're proposing is basically making this move to node like but something.
Yeah,
But how about
periodically replace move to node with move to but wait kind of thing. And you could like hard code that and then procedurally inject it if you feel like, oh, I have a general sense that this tree is not wide enough at this general point, or do a little bit of NLP and inject it when based on your LLM as judge or whatever.
yeah, yeah, like this is actually I don't know. I'm like 50% convinced I'm doing something like catastrophically wrong.
That
But
sounds so fun.
if I'm not doing something catastrophically wrong, I think there's actually a very interesting insight that you cannot teach a model to think. Like to think in a different way that it's non-linear.
Um,
Like,
well, so I have an MCP that I made that's based on the algorithm of thoughts paper. Have you read that one?
algorithm of thoughts, no.
Yeah. It's very similar to like the tree structure that you're going for here, but in this case, like, hey, let's
Yeah,
just take some good algorithms and weave that into how we're structuring our thought process there. And so my
that's basically it.
Yeah, for mine, I think I have MCTS, I have beam search, and then I have like a graph traversal algo, and it can choose which algo it wants to think down.
Ooh,
And then it
interesting.
can choose how long it wants to continue that algo. And then it's just got I pulled the general idea off the Anthropic blog where they were like, hey, if you just give it a tool that's called think, even though it is a reasoning model and can do thinking, that's also useful and tends to increase performance. So I gave it a tool that it
Mhm.
could call called think. And then when it calls that, it has to pick the algorithm and how long it wants to traverse.
That's actually really cool. That's basically the idea, but at every step of it, its reason is it just like receives prompt input, decides manner of thinking, and then thinks all the way through, or can it like change its manner of thinking halfway through? I think that would be crazy.
It can't. I don't. I don't recall exactly. I know that I think it can switch algorithms. I think it has a switch algorithm tool that it might be able to call mid-process, but most of the time it likes to call MCTS and then it likes to just walk it. Um,
Hmm.
what I found. But I would presume that I could structure it such that, if it's in a graph structure, I can represent an arbitrary algorithm in that structure. So what I could say is go, hey, half beam search, half MCTS today. And maybe I could either prompt it to start selecting those, or I could just manually inject that myself, I suppose.
Uh-huh. Yeah, I'm gonna ask the paper this question using the second
Yeah,
thing I'm gonna
dump the
present.
paper and dump the paper into the code base and be like, yo, implement this.
Yeah. I want you to I'm currently reading this paper. I want you to tell me whether or not like the thought process is determined before the is determined before the um, is determined after the prompt and then never changed throughout the thinking process, or if it's ever changed throughout the thinking process. Like it might do a couple of thought executions and then change its manner of thinking halfway through. What does this paper suggest? Okay, good enough. So we'll try this and we'll just go ahead and start running this while I actually introduce what this is. Okay, so question 2, name that file. All right. Okay, so this is the second thing that I was exploring. And this is actually like my implementation of the MIT recursive language models, which is something we presented this last week. I was partial, or like Wednesday. I was partially there, and I have not read this in full, but I think I got the gist. And I just asked. I previously asked like ChatGPT about whether or not this is actually recursive. What was the conclusion? Is this actually recursive, or is it just like a delegation model? Did you guys were you guys there Wednesday?
I missed it.
Hmm. Okay. Yeah, you don't remember? I know you were there. Okay, yeah, 'cause this is off. Okay, so one of the things that I ended up asking, I basically threw this thing to ChatGPT and I asked it whether or not this is recursive, because what it's doing is like inherently, like there's certain aspects that are absolutely not recursive. One is that like it uses a larger model for the first iteration of this so-called like recursive language model. Um, and after it does this after like the purpose of this like first, and I'd encourage you guys to read this yourself. I just read through like a couple of paragraphs on the methodology. That's what I'm basing this on. It basically has this like first large language model. And I think this is not paper club. I did not read this in full. But the thing that I think it's intended to do is to be able to handle high context tasks better than just using like a large model. And maybe there's like a fragment of like this is actually cheaper because you're using like smaller language models. Um, you're using smaller language models to do the thinking and to do the output generation as opposed to the large language model, which um, yeah, it makes sense. They seem to perform better. But I had like a crack at this. And the way I designed this was you have, and if this is complete, great. I'll just go ahead and run it. I'll show you the UI for this.
Wait, question. I know you said you didn't read the paper fully, but is it when they are describing the recursive language model, is it a change in the model or the change in the harness that they're using to interact with the model?
It's a harness. Like it's just completely different. The original root, the original like root agent is just creating functions to compress. It creates functions that compress the original context that then gets fed back into the smaller model for the model to process and summarize. And then I guess the smaller models outputs, and I didn't get this far, but it seems logical. The smaller models outputs are um are like fed back to a different larger model to just like create a complete summarization. That third part is the thing I'm least confident about, but it just seems reasonable.
Got it. Okay. Yeah, it's not germane to this, but I do want to call out a little bit the continued conflation of describing everything as a model. It's not you, it's happening out in the everybody's just like in my opinion, we get much farther as engineers if we are very clear about the different pieces of our
Mhm.
systems rather than mushing them all together and calling them a model.
Yeah. Um, I'll, okay, yeah.
Yeah,
So
that's not about you. This is an industry problem, but
no,
it
no,
is
no, I
showing up
understand.
here. So yeah.
No, I agree. I agree. I'm just trying to think how I'm gonna go through this because I understand the ambiguity. So, okay, I don't know if to call it agent though, uh, because not it's a single LLM call. Like we'll call it an LLM call. There's an LLM call. There's an initial, and I can just show you the code. Um, there is 3 distinct LLM calls. Well, distinct LLM calls independent of the input. We have the delegator, we have the small model, and then we have the conclusion LLM calls. And the delegator is using a larger model, GPT-5 in this instance, and delegates tasks to the small LLM model to the next series of LLM calls, because this is going to output a list of like Python compression functions, functions that have this. Oh crap! It didn't actually like code it the way I wanted it to, but I can show you pseudocode. So this is what I was hoping it would do, which is I wanted to generate a function that does this. It has the you give it the original prompt. Like I wanted to generate the function that is going to do the compression, and as part of the compression, you're going to have an input prompt and an output compressed prompt, and that's the function it's supposed to design for as many times as it thinks is suitable to like capture to respond to the user's question. And so it basically does a series of those, and I think that's aligned with what they're doing here. Is this the right thing? Yeah. Okay. I think there was an example somewhere in here. Okay, yeah. So here's how they go about it. They basically present this like execution of what is it? Return hints. It's finding snippets of code. It's finding snippets of code, and I think it's passing, and I suspect it's passing them over to the smaller language model. That's the way I interpreted it. And so,
Seb, I
yeah,
wanted to give you a heads up. On the bottom right corner of your screen, you have your Zoom window. I don't know if you caught that. If you're
yeah,
able to drag that out. Yeah, there you go.
yep. Okay. So, what is it? Okay. Yeah. Oh no, I just intended to show this one. Not the whole 3. I don't know what the 3. Wait, yikes. You're here for the Wednesday, right? For the presentation of this paper?
Yeah, yep.
What was the conclusion? Is this an actual recursive language model? Like, is it actually recursive?
I believe, or my understanding was that it is some kind of harness configuration, and there is a trained model in there somewhere that's like in a somewhat novel way. But yeah, I wasn't like deeply consuming the content.
Yeah, I just remember there was some ambiguity over whether this was recursive, and my conclusion is that it's not, and you can kind of see that reflected in the code. Okay, so continuing on, the purpose of the delegation model is to create a bunch of these compression functions, along with, and this is my own like tidbit, which is, along with the compression function, you give it like some task for the LLM, for the smaller LLM, that is like more aligned to the actual compression function that it's creating. Because I feel like if it doesn't know about the compression that it's doing and the purpose behind the compression, it may try to like, it might summarize things incorrectly. So this is just like complementing that function, because this function is never passed to the compression model. It is only the compressed prompt. So the point of this is just to like give it a bit of context as to like what the prompt is representing. And so basically once you have that, once you get these like these series, this list of like compression function and some additional system prompt that gives it some context about the compression, it then continues on to where am I? Okay, this is pseudocode. So then it then continues into the small LLM, which is to like summarize the content, the compressed content that it was provided, and to like provide a sort of response. And then once it produces the responses, you continue on to the conclusion. You continue. Well, I think this is where the UI is going to come in handy. Okay, so we'll go here. It's this, yeah. Okay, this is using this is asking the same question that I asked before about like the algorithm paper, algorithmic thinking, whatever you want to call it. This is the original prompt, very long, and at the end you should see here is my question. And then from the AOT paper, this is another thing that I added, the objective, just to, and I'll explain this when I get to the conclusion prompt, but we'll get back to this one. So next, you go ahead to the actual generation of the function, of the compression function, which in this case is like focusing on experiments. Yeah, I'm not going to go deeply into this function or the logic of it, but the idea is here is like it seems to be focusing on like some portion of the paper. So it has the task, compression function, compress prompt. Compress prompt. Okay, I think this is the same. Oh, whoops. Compress prompt. Oh, okay, this is the output. Wait, no, what? Compress prompt. Oh, okay, this is the output of the execution against the original prompt. So this was past the original prompt that we went over here. And the output of running the function against that prompt is this. And then from that, the LLM created this conclusion. And then that is done multiple times with first focused on method, second on evidence, third on comparison, static versus dynamic, whatever that might mean. And then this one too. And then from all of those, it basically passes in all of that information to produce a final response. It passes in all of the information that's basically stored in each one of these blocks, in addition to the extracted objective, with the hope that the combined context of the extracted objective plus this like step 1 and 2 context is going to be less than just this, and therefore might be cheaper to run this third conclusion model. And yeah, I think this is the answer to our question. So the model swap process is notably adaptive during generation rather than remaining fixed after prompting. Oh, so it's suggesting it maybe is adaptive during generation. Very nice. So we just clear out the model capabilities to dynamically address it. What the heck? Wait, it was talking about backtracking to a more promise. This sounds like exactly what was implemented. I wonder what it actually like thought about what the objective was from the determining whether the model stop process is fixed after the prompt or adapts during generation, tries steps, evaluates, backtracks, and changes approach midstream. Okay, so it did capture the objective. Yikes, does this seem accurate?
Let's take a look. I just linked my repo. I don't know. Let me see if I've got actually, let me.
Yeah, I'm gonna throw this text into ChatGPT and see if it agrees.
I got an idea. Maybe oh no, it's not indexed. Rip. Indexing.
Okay. This is basically like the end of my presentation. I haven't like thoroughly investigated as to like how effective this is, and this is my investigation live as to seeing how effective it is. Wait, what? Why is it talking about recursion? Did it confirm? Wow, okay, I have no idea what ChatGPT is on. It seems to be answering like a previous question. What the hell?
So
Okay,
stepping
yeah.
back for a minute, what is the
Mhm.
like meta problem this is trying to solve, and what do we think about this as an approach to solving it?
I actually don't like I don't like this concept. I don't think it's actually particularly useful. I just wanted to see how far it would go. Um, I think that this itself is just not recursive. My interpretation of this paper is just this is not recursive at all. Um,
But I guess the question is like why what are they trying to do here? Are they trying to sort of get to are they trying to solve the sort of auto-regressive
context
nature of things that you where the where
output.
stuff is getting stuck in a rut, and so they're trying to get around that. Like, is that the problem they're aimed at, or are they trying to solve like a online learning problem? Like, what is the
It's a
goal here?
context. I believe it's a context compression problem they're trying to solve. I believe this is designed to allow models to handle arbitrarily long horizon tasks. The goal is to have them sort of like recursively managing their own context such that they aren't such that they are not continually increasing the quadratic complexity of all of the information they're trying to process. They're trying to distill, like, continually distill their own context window during harness operations. Is my understanding in any way.
Got it.
Hmm.
Okay, so to reframe that a little bit, this is about enabling longer term operation on tasks and maintaining the ability to move forward without context poisoning. So kind of an
Yes.
alternate view of what things like, for example, beads is doing within the context of programming, where it's like, oh, I want to maintain a task graph so I can keep something going, and it's not just going to go until it runs out of context window and then stop.
The other thing, or the other thing you'll notice at the beginning of the paper, at least in the RLM paper, is that the way that they have structured this sort of harness model combination is in the same way that you would construct a reinforcement learning environment. So you have an environment, you have tools to examine the environment, and then you can, within the agent is going to evaluate its what it needs to do next. And as such, you could insert a reward function of some kind into that process. So my assumption would be that the goal is to try and get long context, long horizon tasks completed, and then be able to train on them such that the model gets better over time.
Interesting, particularly because as we're sort of describing, like some of this is about model, but some of this is about harness. So you're saying we have a harness that allows the model to do this compression by calling out to other models, essentially exposing a set of tools for context management to the model. But then we also want to train the model on using those tools better. And in fact, maybe those tools are themselves moldable, where it's influencing the prompts of how it, like in a DSPy style, where it's like tuning the prompts over time.
Yeah, I believe the goal is to say like, okay, if the world that you live in, dear model, is entirely made out of text, well, let's turn that world into a reinforcement learning environment such that we can dial in what kind of reward functions we want to give you if your entire universe exists with produce more text as the thing you can do inside of it.
Hmm. And the point is that the amount of text to like represent a real world would be like impossibly like large to fit into a model, and therefore you need these compression methods.
Uh, sort of, or more that um if what you do is take a first principles approach, right? Of like, hey, we want to do reinforcement learning on this model such that it can spend additional compute during inference to be better at whatever it's doing, right? If that's what you want to
Hmm.
build into the structure of whatever training run you're doing, then you're going to want to train your model and set up your harness such that you have like a robust sort of explore exploit ratio built into that environment by default, so that when you're training, you can zero in on the points that are good for long horizon tasks and that are bad for long horizon tasks, and you can kind of differentiate between the two.
Hmm.
If you notice, there's like a
Yeah.
certain type of context that continues to come up during, let's say, like an agent that's supposed to assist with legal proceedings or something, and there's a certain
Hmm.
kind of there's a certain statute that whenever it comes up, it always gets like massively compressed. And it seems that whenever that compression goes up, your users start reporting, oh, okay, like this is a helpful assistant as opposed to an unhelpful one. Then you can go back through all of your traces because you've set up the environment in such a way where like, oh, that's just a part of this environment that you live in model. So you should avoid that part because people don't like it.
Mm. Yeah, I guess that's kind of destructure that like compression problem. It makes it more auditable for sure. Like all of this is information that is like present throughout the pipeline.
Mm-hmm.
Um, it's yeah,
Because you can
it's a
also
lot more interpretable.
you can use that if what it can do, if it has some creative license, if it can make some decisions about when it needs to backtrack or when it needs or how much compression it's doing or what kind of algorithm it's doing, you can use that as another signal to train on of like, oh, when we compress this down to
Mm.
n-grams, that's actually much more helpful in um the larger context to just keep that weird little compression artifact in this long horizon context window because like the model just happened to land on the right kind of compression for that kind of information.
Yeah, just cleaner feedback. Yeah, that's an interesting point. If you can destructure the steps, it's a lot easier to like refine. If you can assign responsibility to a single step, same as like chain of thought. And there's also like chain of programs. I don't know if you've heard of that. I was meaning to look into
And
that chain
in
of
principle, it kind of makes me think of like Dreamcoder, which I think is a similar principle
chain
here in
code.
that what we like because that was how they used to do um generative modeling, right? Was they would do program generation and execution. They would just like have Python generate more Python kind of thing. Um, so this is, I guess, like sort of trying to take that concept into the world of LLMs where instead of just raw text token processing, we're actually just going to have you kind of continue to try and find your way to the approximation of this function because you model are a universal function approximator. That's what you're made out of, kind of thing.
Yeah.
So this makes me think of sort of a technique that Manuel and I have been talking about a lot and jamming on a lot, which is essentially like it turns out to be much more efficient to generate code by taking a couple of steps, right? Where you say, generate an interface, now generate an implementation for that interface, now generate code that uses that interface,
Mhm.
rather than generate blah, 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 right? And like you sort of,
Generate all three at
yeah,
once.
exactly. Well, and like I use the word interface. You could also use the generated domain specific language for this, right? But like
Adding more
essentially,
constraints.
yeah, create the concept layer, independently implement that concept layer, but now create the code that manipulates that
Mhm.
concept layer. Like creating those layers of separation both seem to dramatically increase the um, accuracy of generation, probably by reducing the scope of things you're trying to do all at once, uh, but also reduce the amount of tokens to get to a particular amount of functionality. I wonder if there's a similar thing here with regards to non-code reasoning or things like that, where you could say, compact these different things. You're sort of doing this right now, and or your nodes had a little bit of this. So maybe that was more of
Which
a
one?
progressive disclosure thing where you had like the summary and then you had the reasoning. But I wonder if there's a piece of
Oh
like
yeah.
create a concept library or create sort of a set of different concepts that you want to manipulate
Hmm.
and have those be expandable, but really then try to do a generation at the level of the concept layer or concept manipulation. I don't know. I'm not like
Huh.
fully expressing this well, but I think
No,
the
I like it. The
the
standard library, but the for conceptual maps rather than for
yeah, and then the other
Hmm.
piece of that though is that like for LLMs you can create domain specific standard libraries, right?
yeah.
So like whatever problem you're trying to grapple with, first express the vocabulary, define the useful vocabulary, now do reasoning in that vocabulary. Like, can we create that level of separation? And is that helpful when we're dealing with non-code problems? I'm very clearly convinced and have applied quite a bit of evidence that it is very helpful with coding problems. But I wonder for non-coding reasoning problems if it would also be useful.
Yeah,
Yeah,
that's
I would guess yes.
with math. With math, I can very easily see that. I think just research too. Just like research, it is based on like, well, you're experimenting different methods. I don't know if that's it can still be the same concept that you're exploring in research, but just exploring different methods. So I don't know.
My
We
other
should go ahead.
oh yeah, we're since we're waxing philosophical, I suppose my the angle I'm thinking of on this is the way that I see that what you're saying, Kevin, is that is like if we have a total search space, let's constrain it, then allow exploration inside of it. Then let's reconstrain it after that initial exploration. So we now have two layers of constraint. We have our UI and then we have our functions. Um, or we have our UI and then we have our DSL. And then now let's match constraints. So we have DSL and UI that's going to describe UI behavior. And then let's add a new constraint that says, okay, now make this real. Now give me the code that's going to do this. And the angle I'm thinking of is that my personal process is sort of like it's a similar thing, but it's like in reverse, where there are like multiple angles you could try to attack this problem from. So that like I'm still on the like spec driven development train, but mine feels a lot more like linear and straightforward. I start with the spec, then then I run test suite, then I add failing tests, then I move through that constraint set until I'm complete. Um, which is one could also while I was in theory doing it this way, going bottom up, I could also take a top down approach where I go on to another side and I go, actually, I want to do a significant deviation here. So rather than specking it out immediately, let me just grab like
The
generate a
test.
couple of UIs and then grab a DSL and then be like, hey, can you start making failing tests in this direction if I want to add this component kind of thing? And you could attack it from bottom up or top down at the same time, kind of thing.
Yeah, I think that's on target. I also think, and to be clear, like a lot of this is still very exploratory and
Oh yeah,
something that I'm
super
like sort of
exploratory.
fleshing around. But like I think some of this comes to this area of this concept of context compression and context window, right? Which is like if I have a flat spec, and to be clear, I do a lot of development that's spec-driven development with a flat spec still. Like there's a lot of stuff that happens in that world. But if I have a flat spec and I'm looking at that spec and all of its acceptance criteria, and I'm looking at all of my implementation, like fundamentally, that's a very large set of context. I'm probably going to have to conceptually essentially page over that or have the LLM page over that where it's doing pieces of it at a time. It's hard to have the whole picture. It's hard to reason across the whole picture at any one particular time.
Yeah, and
But
LLMs are great for that. Yeah,
well, they are, but they also aren't. They the larger that picture and the more paging that's going on, the more likely something is fixed or goes out of sync or goes like is wonky. And so the sort of DSL driven approach is saying, let's introduce a couple of layers of abstraction so that you shrink the context window in
yeah, like
which
fuzzy
you're
maps on top. Yeah,
yeah, putting maths on top, whatever. So it's like, okay, let me design a DSL that lets me express this problem in a way that fits in a very small context window and prove it correct given the DSL works. I can implement a solution with tests and all of this given the DSL. okay, now let me go and do each one of those DSL functions and have that be its own full context window, or like full scoped down to just
Yeah.
this, and prove my implementation of that is correct. Right now, I have, just by introducing that one layer, DSL is domain specific language, if you're Googling for it.
Yeah,
Sorry,
yeah, yeah.
throwing
Very tough.
jargon in there. That's
Mm.
kind of Ruby and old
Manuel's
school.
favorite word, puberty.
Manuel's favorite. Yeah, I live immersed in parsing from him, so then I pick up some of it. Um,
Mm.
but if I'm able to, even just introducing that one layer of interaction, I dramatically scope down the size of what needs to be in context to do reasonable reasoning, and also to be able to prove correct. And that dramatically increases my ability to generate with high fidelity and validate.
Mm. Yeah, I was reading into OpenAI's methodology for compression. And in case you didn't know, OpenAI has like an endpoint for compression. Um,
Really? Hmm.
yeah. It was unraveling
Oh, that new article.
codecs,
Nice. Cool.
something. I don't remember. I can send it
Yeah, I know
later.
the article you're thinking of. Yeah.
Yeah. So they basically publish the way that they do compression is I think the main takeaway about the way that they do compression is I expected it to just be like a simple summary of all of the context that existed. You throw it into your user message. Instead, it actually like tries to preserve some of the structure of the context history.
Hmm.
So it, instead of just making it one user message, it might actually make it like a series of user assistant messages. Um, and another interesting part is that for the compression, it actually um, it doesn't seem like it doesn't take into account the amount of context that goes in from the tools. Like it doesn't know how many tools you're calling. It doesn't know how many tokens are being consumed by the tools. So that is another interesting thing. Um, they didn't go much further than that, but I just wanted to share that tidbit that they actually like tried instead of just like making it one gigantic summary, it can be like multiple messages. They
Yeah,
try to maintain the structure.
responses API has evolved to support a special responses/compact endpoint.
Yeah. And they manage it via their responsive APIs. So
Hmm.
yeah, cool stuff. If nobody has, well, my presentation has been over for a while. We've just been chatting.
Yeah,
I
we
was
are. Oh, go ahead, Yikes.
Oh yeah, I was just gonna say, in my I was just checking my old reasoner, my reasoning, my think MCP. And I do apparently I am tracking the parents, and I am also asking, do you need another thought after this? But I didn't add a backtrack function, so I might add one, and see how that goes. I don't know. He doesn't. I
Yeah.
find they don't really need this MCP much these days, but I don't know. I'm gonna tinker with it again. Interesting.
I, I think I can add something like as I was reading, as I was thinking about like what is a recursive language model, and kind of like struggling to understand how the paper was recursive in the first place. Kind of realized that like it still would be interesting to see if a model can like be recursive. And something that I was thinking about is if you can make like a single function that allows the model to like focus on different aspects at a time, like kind of like a combination of coding plus a combination of like creating a function with in a terminal condition that is always going to be like is the objective complete, and otherwise you just continue going through a series of functions recursively that has dynamic inputs based on what the function thinks it should be addressing. I think that's still like an interesting avenue of exploration.
Hmm.
Just being able to like weave in more seamlessly like coding compression into a problem, and maybe it's not even compression. Maybe it's just it might not necessarily be compression. Like with code, you can do anything. So sometimes just like shifting focus and maybe doing a coding analysis in between every like thinking step. It's just something that's been like on my mind that I think might be interesting.
All right, so to just to throw out a little bit of a tidbit, and then we're there. Like, and so again, I think giving the LLM the ability to write and execute code is the superpower for a very large number of these things. It,
Mhm.
but like many superpowers, it is also dangerous in a lot of ways. So once again, like one of the
Sure.
techniques that Manuel and I have been jamming on a lot, and I mean, I say that we've been jamming. He's jamming, and I'm providing thought back and forth with that I will share. Like he's ridiculous. He does so much, but is essentially creating sandboxed VMs for code execution with tightly scoped uh, particular DSLs that you might expose in there or data access, but it gets to the same concept of control the interfaces you give access to, right? So in this case, you might say, here's my data that I'm willing to let this LLM have free reign of. Here's the interfaces I'm willing to give it that access outside of the system. But within that, let it YOLO code and
Yeah.
use code to manipulate anything that it wants within that scope of what you've determined it have access to. Because if you give the LLM access to code and a database, code and SQLite, use SQLite, whatever, um, it gets dramatically more powerful without you having to tell it how to do it. It will just do it and do all sorts of interesting reasoning. Design yourself a task graph in SQLite, use it to execute on this task, write code as needed. Like
It's interesting. Because yeah, I rely pretty heavily on my task graph for while I'm working. So the ephemeral task graph of like, hey, you have SQLite, just do this, is an interesting thought.
it is
Huh.
shockingly powerful.
Interesting, interesting.
Wait, what is repeat the shockingly powerful thing?
Tell the LLM you're doing this task, use SQLite, design tables as you need them, and use them. Because now it has a fully
Oh,
flexible and queryable context management interface without any of
wow.
this you writing code or thinking about how to do it. It just does it, and it does a shockingly good job. And you can say
Well,
write a
it is
task
writing.
graph. Do yeah,
It is writing a table essentially, and then
or a set
querying
of
it.
tables. And
Mhm.
they're task specific. You don't have to think ahead, what is the right way to design this? Let it do it for its purpose
Yeah,
in this task.
And then like, hey, do you need a Claude Code hook? Because that's where you live right now. Like,
Yep.
you can just write one. Oh,
yeah.
So
Very
that gets
cool.
you a very long way. The place you then run into is, yeah, how do you lock it down when you need to lock it down, keep it from deleting all your other databases, etc. But you can do that by exposing exactly what you want to expose via an interface into a sandboxed VM and say, this is where your code goes. It goes in there. Okay. Anyway, we this could
Yeah,
be several discussions and sessions. I'm going to try to
always.
get Manuel to
yeah,
show more of his stuff on it.
Yeah.
But we are at time. Thank you, Sebastian, for taking the reins and running this today, and
yeah.
then
No
rolling
problem.
with our sort of improvised discussion afterwards.
Pleasure is all.
Um, and thank you everybody who showed up, participated, or just listened. Even in the chat, appreciate the participation. This could be you next week or the week after. Please do sign up with the bot. We rely on all of you all to keep this going.
At
And
AI in Action Bot in Discord.
yep, and it will be good. It doesn't have to be polished, doesn't have to be useful, just has to be interesting. But take care. Happy Friday, everyone.
All right, bye. Thanks.